let us look at two more important results from chapter 11, which are the Cauchy's mean value theorem and the L'Hopital's rule. So Cauchy's mean value theorem. Cauchy's mean value theorem. So Cauchy's mean value theorem is slightly different from your standard mean value theorem. Otherwise, we would need a separate theorem, right? So here's what it says. If f and g are continuous functions, f comma g continuous on a to b and differentiable on AB, then there is a number that then there is a number x such that in AB such that f of b minus f of a times g prime of x is equal to g of b minus g of a into f prime of x. Okay, and note, this is not what you would get if you use the normal mean value theorem. Note, normal mean value theorem would give x and y different numbers such that let me change my colors. F of b minus f of a multiplied by something is equal to g of b minus g of a multiplied by, this would be g prime of x, but this would be f prime of y, right? If you use mean value theorem, it would say, oh, there is some x such that this is happening, there is some y such that this is happening. There is no guarantee they need to be equal. This one says you can find one number such that they are equal. Okay, so proof. Well, consider h of x is equal to f of x times g of b minus g of a minus g of x into f of b minus f of a, right? Then f is continuous, then h is continuous on AB and differentiable on open interval AB because it is a linear combination. It is a linear combination of two such functions, right? Both f and g are differentiable and continuous on the intervals. You are multiplying by gb minus ga, which is a constant, and fb minus fa, which is a constant, right? So this is continuous and differentiable with, and h of a is equal to f of a times g of b minus g of a times f of b, which is equal to h of b. This is easy to check. Plug in a or b, you get this exact same result. Therefore, by Rolle's theorem, we get there exists there exists x in AB such that 0 is equal to f prime of x times, well, let me say this, 0 is equal to h prime of x, which is equal to f prime of x times gb minus ga, since that is a constant, multiplied by minus g prime of x times fb minus fa, again, which is a constant, right? And therefore I can write g prime of x times fb minus times fb minus fa is equal to f prime of x times gb minus ga for this very special function, a special value x.